Michael Yuan from Wasmij will then discuss the concept of write once. Run anywhere but for GPUs, which is especially important for infrastructure and architecture at the edge.
Yeah, but I want to do a demo.
Oh, you want a demo? Okay.
Okay. In fact, let me do the.
一个 layer，
Excellent. Okay, can I start?
Yeah.
Okay. All right, so hello everybody. So my name is Michael Yuan, and I'm the creator of this project called Wasmij. So we are one of the CNCF Linux Foundation projects, and we provide WebAssembly-based runtime. So people keep asking me, why do you start a WebAssembly runtime? That was back in 2019, and I keep telling them that I made most of my money, from the Java days. And back then we had a thing called write once, run anywhere, but it's mostly about operating systems and CPUs. But in the new era of computing, that we have opportunity to do it for the GPUs. So that's what I want to talk about. So there would be a lot of, in fact, there will be a lot of demos and during this talk. So we have I have a GitHub repository that has all the scripts. So if you want to follow along, you can do that. And the goal is really by the end of this talk, that you would have a large language model running on your own device, no matter what device it is. It could be a Linux computer, it could be a Windows, could be Mac, and so you would have a large language model and agent running on your device. So I wrote a couple of computer books in the past, mostly for O'Reilly, Anderson Wesley, Prentice Hall, and all that. So about a year ago, many reached out and they said, Michael, why don't you want to write? Do you want to write a book about large language model LLMs, because we saw your work, you're active in that area. So I thought that may be a good idea, but then I find out there's no way to write an AI book in this day and age, because as soon as you finish, in fact, as soon as you finish a chapter, it's become outdated. So there's it's impossible to write the book this way. So I told them that I would only write it if that's an ebook. So so that's the outcome. So it's a three chapter project that actually goes over a lot of the stuff that we talk about today. So enough about advertisement. And so let me start with a claim that is, I think it's somewhat contrarian and maybe unexpected to a lot of people, is that I believe large language models are inherently tightly coupled. Okay, so we have been pursuing this idea of loosely coupled application or microservices for a very long time. I know this is widely used in this company. That's however, when large language model first come out, it's pretty much follows that line of thinking because OpenAI provides API. So you write application that talk to the large language model through API. And then there's Anthropic, there's lots of other models. There's open source models where people still use this SaaS paradigm. That's I provide API, and then you have a Python application or you have some other application that interact with the model through a workflow management or function calling, something like that, right? However, I would argue through a lot of applications that we see, especially local applications and edge applications, that is actually the wrong approach to it, because there are a lot of things today that requires tight coupling between the model and the application itself. So for instance, we have all had this idea, this experience of when OpenAI changed to another model from GPT 3.5 to GPT-4, all your prompts stop working, or a lot of them stop working. We introduced the function call. Different models has different ways of describing function calls in their return tags. So, so there's lots of applications that you saw it's running correctly, but it's no longer run correctly when it's changed to another model. And it's also the same for the inference, for the runtime and inference side of things. So say if you use Ollama to run Llama 3.1, and then Llama 3.1 had another minor update and change their encoder in some slight format, then your Ollama runtime has to update with it. Because if you don't update it with it, it would not be able to run the new model. Although the model is the same, the weight, the architecture is 99% similar, but you need a patch to the underlying runtime in order to run it. And this list goes on and on. There's not just the prompt, but how you set up the vector database, how you set up the knowledge, how many dimensions do you have in the vector database? How do you do retrieval? Do you do graph retrieval? How many chunks do you? How do you chunk your knowledge documents? How many chunks do you retrieve? Do you reorder your retrieve chunks? And things like that. Everything is hugely model dependent. Depending on the model capability, that you would require a different way of writing an application. So that's a conversation we also had, just today, is that, we have a lot of applications prototyped on ByteDance, Doubao, models, but then we move it to GPT and then it would stop working. A lot of those workflow prompts would stop generating the answers that we would expect, right? So the solution for that really is, so that leads to the need for write once to anywhere, is that we believe that a lot of those production applications or agent applications would need to be tightly coupled with model, meaning that they are distributed with the model. In a system like a Docker image or a container, that you have the model files that frozen at some time and has a runtime that's matched to that model and have prompt, have a vector database, have everything else all packaged together so that you can upgrade them together. So there would be no chance, say the model updated and the user downloads a new set of weights, then the application breaks, right? You package everything together and then distribute that through a software package, right? So that's, I think the basic thesis that we have, is that why you need to, have cross-platform model runtime. So in order to keep, illustrate this point, I would do a couple demos. Perhaps the first is the most important. It's actually a very simple demo. So we have the background of this demo is really, a question my son asked me. So he's at the time he was in middle school, so he's interested in chemistry. So he go on ChatGPT and ask, what is mercury? That's he meant the mercury is the element, right? The metal. And ChatGPT answers, Mercury is the innermost planet of the solar system, blah, 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 blah. It answers Mercury is a planet, okay? So he thought that was interesting, but it's not a big deal. So he would change the prompt to say, I'm asking about the chemical elements. So ChatGPT returns and answers the question about, it's a toxic metal, it's liquid at room temperature, and blah, 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 and all that. This was largely correct. There are some inaccuracies in the answer. And then I thought that's what's most interesting. He asked the follow-up question to say, what is the melting temperature of mercury? As we all know, as the model itself has stated, mercury is liquid at room temperature. So the melting temperature of mercury would have to be pretty low in order for it to be liquid at room temperature, right? But the model answers is 400 something Fahrenheit. So at the time, I was very puzzled. Why would it get wrong? Such a simple question. That then it occurs to me, the surface temperature of Mercury, the planet, the innermost planet in the solar system, is 400 something Fahrenheit. Okay, so you can see how the model confused those facts together. That's So if I'm going to use ChatGPT as a chemistry teacher, like my son would want to, that's it would not be able to do that, because the model and the prompt is not designed to answer this specific type of question. So in order to do things like that, we need to package a chemistry-specific data, specific set of knowledge base with a model that doesn't really have not much chemistry knowledge or astronomy knowledge on its own, so that it would not confuse those facts because it doesn't have those facts to begin with. So that gives the whole idea of small large language models, SLMs, plus highly specific domain knowledges, right? So this is essentially those three steps we do. So we took, we have a software package in one of our community members who did the project called Gaia. And this is one of the projects that combines the vector database with the Wasm-Edge model runtime with a large language model. So you can choose essentially any model from Hugging Face, and then you can supplement it with your knowledge base. So what they did, as my son did, what he did is that he took the chemistry textbook and then build a knowledge base from it. And then you can start that node and start chatting with it. And so I would do this demo by going through the process. So I would skip the first process, which is installing software, because I already have the software installed. And so I'm gonna just copy and paste the second command. And by the way, this is just my Mac laptop. So it's a very old laptop. So the saying really goes, that's 2 years ago, right before ChatGPT came out, I'm due for a new computer. So my assistant asked me, what type of computer do you need? I said I wanted the cheapest Apple computer possible because it's all overpowered. Only thing I need is get to the internet and write some code, right? Now I'm using it to run large language models. So that's so I really regret my choice. But that's so the next computer I'm gonna get the largest possible memory. But anyway, so I run this command on the command line, and you can see what it does is that it's check whether the large language model is here locally. I have already pre-downloaded, so it's here. It's a standard Llama 3.1 8B model. And when I go to conferences and ask people to do that, that's people would actually try that, and then it would bring down the whole conference Wi-Fi because they are each downloading a 5 gigabytes, large language model. But here we're gonna have it. And we have a Quadron database, vector database installed. And what this command really did is that it goes online to download the chemistry knowledge base and put that into the Quadron, right? So now what I'm gonna do is I'm gonna do GaiaNet start, which basically starts the large language model with the vector database with a set of prompts that makes the large language model think it's a chemistry teacher. Okay, so so it's so basically it's there's a configuration in this package that allows it to come up with a command that start Wasm-Edge and start with the large language model that we chose, which start with the embedding model, which is the AI model that's specifically turning language into vectors so that it can be searched in a vector database, right? So now it's also so now it says it started. What I'm gonna do is I'm gonna go to localhost so that I can make sure it's runs locally. It doesn't, so this doesn't go, if this is not being broadcast, I'm gonna turn off my Wi-Fi at this point, just to show you this is entirely local. There's nothing that's on the internet. So I would start and ask a question, a somewhat difficult question. What is the atomic weight of mercury? Sorry. Okay, so The answer to the first question is a little slow because it has to, load all 5 gigabytes of, large language model into the memory and then do the inference, right? But it's going to be faster in the second one. So as you can see, it gives a highly specific answer. If you just ask ChatGPT or vanilla, Llama 3.1, it would not be able to provide this type of answer. It has a very accurate description of what is atomic weight. By the way, the atomic number is 80. So a lot of people confuse that, because the atomic number is how many protons it has in its nucleus, but the atomic weight is a combination of protons and neutrons, and because it has isotypes. So the atomic weight is not an integer number. So it goes like this. So it's a weighted average of all the isotopes of mercury, right? So it is I think it's a highly specific chemistry answer that it gave because the large language model itself is fairly small. It doesn't have a lot of knowledge, that's first. It doesn't have a lot of things to confuse itself. And second, we have a highly specific chemistry textbook. So I ask another one, which a lot of the our Chinese friends would find familiar. So let's say, what is copper sulfide? So this is a chemical compound that is very commonly used. If you are going through the Chinese education system, that's it's been tested again and again. This is a compound that's when dissolved in water, it's going to turn the water into sky blue. Okay, so if you ever see the exam question to say the solution is sky blue, there's some there's this thing here. So it's yes. So it gives a fairly detailed answer of what it is and what is the chemical composition and things like that. I can go on and ask the type of chemical reactions. What if I mix this with, say, another metal? The other metal would have a replace reaction and replace the copper out of it, and things like that. So so we turned Llama 3.1 into a very capable chemistry teacher by feeding it highly specific data about chemistry. I think that illustrates the importance of tight coupling. So you have application. The application is not just a large language model running somewhere. But you have a specific attribute that you want from the large language model, and you have a knowledge base that supplements it, right? So, I'll stop this demo because I can go on forever. But but I do want to show you something else, which is actually quite interesting to also relevant to the demo that we just saw about the coding demo, right? So what we did here, it actually have voice, but is that a voice? Oh well, so so I just talk it over. So essentially, we have all seen Cursor, the coding IDE, right? You can connect with cloud or whatever to do coding, but a lot of those models are not really good at Rust. They are good at Python. They are good at JavaScript. So we have a Llama 3.1b model. We have a graduate student from ITT India, and we ask him to convert all the public Rust language knowledge into a knowledge database, then supplement that into that model, and then connect Cursor with that model, right? So this is essentially one of our product manager, and she has no Rust experience. She has never coded Rust in her life. So I asked her to record this demo. So what she did is that she goes to the node first, then asks, how do you start a Rust project? She said, use cargo create, right? So that's what she did. She said cargo create. So now then she goes to this node, and then she, so she connects this node, she connects Cursor with this node. This node, right, it's what we call, it's the same as the chemistry teacher. So it's a Llama 3.1 large language model. And then, you add this to Cursor as one of the nodes and turn off every other node, right? Turn off all the other large language model backends. So now she can use it. So, so she comes to the IDE, let's wait. So, yeah. So she used a different URL that's replaced the OpenAI URL with our own large language model that's running on Llama Edge, right here. So now she goes to the template file, the main.rs, which is the hello world, in Rust. And she said, I want to do a to-do app, okay? So I want to write me a to-do app in Rust. What it does is it goes to the model and asks how to do a to-do app. And the model returns something like this. And this is something I thought was very interesting because this literally did a to-do app, just to print a bunch of to-do items. And this is not what we want because we want logic in the application. We don't want the application just print a bunch of to-do items. So she said, support adding and deleting items. So, that's not what I want. I want to support adding and deleting items. Now you can see the model generate much better answers. You know why? Because it has seen applications like this in its knowledge base, not in its training, but in its knowledge base. So so it goes on to generate applications that use a vector to store those to-do items. Now you say accept, so you have all this, but being new to Rust, she doesn't even know how to compile and run Rust. So she on the chat window, she said, how do I run this Rust program? Now you write this Rust program for me, but how do I run it, right? So then it gives a detailed explanation of how to install Rust, which she already did. But there's so basically it goes on and say use cargo run, right? So at this point that she would go and say, okay, let's see. Yeah, come on. Okay, say cargo run, right? So she would do cargo run here. Okay. And cargo run not only compiles the application, the cargo build. Oh, by the way, when she did cargo build, it says it's wrong, because the Rust compiler is very unforgiving. As you can see, because it puts the markdown here, right? But being a Rust newbie, she doesn't know that. However, the IDE already knew that. So the IDE got this error message and automatically sent back to the large language model to ask the large language model what is wrong. Large language model tells you what's wrong and how to fix it. So now she sees that she fixed that. Okay. So so she asked how to run the model, how to run the application, and then she used the command to run the application, and then she find out, that's it didn't work. Now she compiled and runs, but another problem emerged. As soon as she runs, the application quits. It doesn't print anything. So she come here and say, how do I interact with it? The model looks at the code and then tells you that's because the code is written this way. Here's a loop, and then that means once you start the application, you should not enter a return immediately. You should select from one of the menus, right? This is one of the command line applications. So so she saw that, and then she go back there and do the run again. Let's see. So it's almost finished, and yeah. So she'll come back and say cargo run. And now she doesn't hit enter. She says, add a task, view task, delete task. Now she say add task, and then say buy milk, right? Then it would be saved into the memory of this application, and then she would say view task and tell her that you have a task outstanding that is buy milk. So so this, we have a couple of videos like that. There's we trained build model applications that has again, we would call small language model with a specific knowledge base. And we can go all the way to Alibaba's Qianwen 0.5B model. 0.5B model can, I think it's only 200 megabytes. And if running on the CPU without the GPU, it can get to 100 tokens per second. Okay, so it's a really fast and a really good model. It doesn't really know much, without supplement knowledge base, but if you supplement it with a knowledge base, it can know a lot. It can know how to program in Rust and things like that. So let me go on. And so now I hope I have established the need to do the integrated large language model with the tools and with the knowledge base. So you build the whole application together and then distribute the whole application instead of using the large language model like an API, right? If you need to build an application and then compile and distribute it with large language model embedded in it, then the problem then you encounter several immediate problems. The first is that there's a problem with Python because if you look at any Python code that runs those large language model like PyTorch, it actually surprised me. Do you guys know how big the PyTorch Docker image is? The dependency PyTorch need is 8 gigabytes. Okay, so the PyTorch Docker image is 8 gigabytes, and so it's gigabytes and gigabytes of stuff that you have to build into your application if you just want to use Python for it. And plus, the Python is not going to be cross CPU and cross GPU anyway. In Python you have to have a CUDA specific commands in order to run the model that with CUDA, right? So that so that's why most of those applications do not distribute it as a Python image, because if you distribute agent as Python image, that's fine, but that's assuming the model is available somewhere else through an API, right? That's so the Python is just the workflow, just LangChain or Llama index, whatever, right? But if you want the whole application written in Python, I think you're going to embed PyTorch. That can be a huge amount of task for you to do. So that's actually not just I'm thinking that, so we all know this guy, right? That's so someone said, AGI will be built with Python. Let that sink in. And he replied, Rust. And Greg Brockman is the CTO of OpenAI. That's his famous tweet is that, that's much of modern machine learning engineering is making Python not to be a bottleneck. Spending a lot of time installing Python and try to figure out why it's so slow, right? So the first thing that we rule out is that building application in Python is maybe good, for prototyping, maybe good for agent, but not good for highly integrated, tightly coupled large language model applications. So the second one is really that's then if not Python, and why not just C++ or Rust, whatever, right? So the problem with that is that it goes all the way back. It brings all the way back to 25 years ago when Java first came, right? Is that if I have a Windows machine and I write an application, then I can't deploy this application to my Linux server anymore because it's different APIs. It's the same thing today because we have so many GPUs today. So it's my application that's written for the Mac and running on the Mac would have zero chance to running on all of those. That's because they are all different hardware architecture, different software drivers, and things like that. So I thought it was very interesting. I'm going to borrow a line that directly from one of the earlier speakers is that the solution for that, like anything in computer science, is really just to add another abstraction, right? Is that so in our world, this abstraction is called WASM. It's called WebAssembly. So so you can have C++, Rust, or any native language, Go, or any of those languages, and compile them to WebAssembly, and then not care about what kind of hardware you are running beneath that anymore. Okay, so meaning that if I develop something on the Mac and I compile to WebAssembly, I will be able to run on all those devices. Although it's not the reality today, but we have done this, we have done this, we have done this. So we are in the process of doing this.
Graph people are coming tomorrow.
They are not open source. We don't have an open source SDK. You should convince them to do open source, right? Yeah. So
Ask the questions when they present tomorrow.
exactly. That's how open source community work with you guys, right? That's we're working with ARM as well. So yeah. So then I would have a final demo. That's I think I may have 10 minutes left. So so it's for this demo, I would not do a live demo because it's fairly complex, and I would really worry about to mess it up. So what it does is that I first build start a Docker image on my Mac machine, and in the Docker image it has emulated ARM environment, and it has Linux environment, but it doesn't have any of the CPU features that the Mac has. So the standard Docker, when you start up Docker, it only have CPUs, right? So on the Docker system, I compile the Rust application that I wrote into Wasm. Okay, so the reason I do that is that I want to show you that I'm building this application on a system that doesn't have GPU at all. Not as hardware, not driver, not anything, and not library, not anything, right? So now, after I'm compiling it, I'm not compiling it to a native application, but I'm compiling it to a Wasm application called llama-chat.wasm. Okay. So now I switch back to my host Mac. On my Mac, I copy this file from my Docker container. Okay. So in the Docker container, I have no GPU, but outside of it, in the host, I do have GPU. So now I'm running a compiled binary application that was compiled in the CPU environment and try to run it in the GPU environment, right? So now I started it, and then I say, plan me a 2-day trip to Tokyo, because I gave this talk at Tokyo first. So so this demo, actually this demo has a Japanese version. So there's a blah 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 goes on. First day goes to the Qiancao Si, then it goes on and says, that's so there's that's it gave a pretty good explanation of how where to visit in Japan, right? And it's pretty fast. The reason I'm also showing this is because this is all real time. This is not a speed up recording. The only way a Llama 3 model can output text this fast is through a GPU. Through a CPU, it's going to be like the first day is blah blah blah. So this is actually faster than I can speak. Now I go to an Azure machine that is running NVIDIA T4 GPU, okay? So now I do SCP to copy this WASM file to the Azure machine. So I'm copying the binary application. I'm not rebuilding. I'm not, adapting it in any way. I'm just copying the binary application. So on the Azure machine, on the NVIDIA T4 machine, I'm asking a different question. Plan me a 2-day trip to Hong Kong, because the second time I gave this talk was in the Hong Kong KubeCon. So that's, but it gives much shorter answers, I guess it's, I actually don't know why. So let's translate the above trip plan. Why would I translate to Japanese? Shouldn't I translate that into Chinese? But anyway, so that's
Okano-san, we need your translation.
yeah. So those are, so this is, I thought that demo was interesting in a way that it's compiled on the CPU only machine, but runs on 2 different GPU machines that has very different GPU hardware. One is the Mac GPU with the software is the Metal framework. The other is the NVIDIA GPU. The software is CUDA framework, right? So we have something that's that at the binary level cross-platform. I think that's especially interesting and also important because it's say if you think about things like how the current cloud infrastructure is set up, like Kubernetes. Kubernetes is designed to orchestrate binary files only. It is not going to recompile your application on a new machine. It's just going to copy your application to a new machine, right? That's why there's so much headache. That's say you have a new machine that is AMD, not NVIDIA. That's I would have very detailed and error-prone configurations in Kubernetes to make sure that I'm orchestrating the AMD image to that machine instead of the NVIDIA image, right? So there are lots of work and a lot of headaches. That's that's what's involved in that brought us, I think set us all the way back to 1995. That's the days that we don't. That's pre-Java, right? So let me see. Well, yeah. So that's so basically we are going to a new paradigm that's where developers just write those applications using what we call the WASM API and compile to WASM, and then let the ops figure out. So this is a slide that shows you how simple this application is. So I would also like to boast that this is the entire core logic of the chat application you've seen. You've seen the loop. You've seen how to send the data to the context and then get the data from, send the data to the large language model and get the data back, how to construct the POM. The whole thing fit into one slide, right? One PPT. That's all the code the developer has to write, right? So then let the ops figure out which version of the driver and which version of the WASM Edge runtime they need to install on the machine. It's the same thing that if you have a Linux machine, you have AMD machine, you have to install the AMD version of Linux, right? If you have say that's ARM machine, you need to install the ARM version of the operating system. It's the same thing. The ops people have to figure out the correct driver and runtime that they have to install on that machine, so that the orchestrator or the or Kubernetes would be able to orchestrate those WASM applications across those the boundaries of those devices and have them run anywhere. So anyway, I think that's it. That's I have a. Do I still have time?
You have all the way to 3:20. You have 7 more minutes.
Oh, okay. So yeah, well, if you have questions, you can ask me now because I have done most of my talking. But as last thing, I really just want to show you another project called Moxie. This is one of the cross-platform UI for large language model. So it's we leverage the cross-platform Rust UI, and because as you can see, all the things that we did running large language model and things like that is based on the command line, which I'm sure you all are very familiar with. But for the new person who has never done command line, like some of the graduate students my wife has, that's they're business students, and they were like, wow, do you really expect me to do those command line stuff? So we have a GUI stuff that allows you to we have Mac distribution, Linux distribution. It's all written in Rust, and you can you can download it, you can install it, you can select large language, you can search, you can select large language model, you can install it, and then you can chat with it. And then there are a lot more functionalities like function calling and things like that, because running locally on your machine, so you will be able to access your machine to do things like make phone calls to people, send an email, or set your alarm, or things like that. This is also I think a very good example of a tightly integrated application. That's you have all those features that ties the application with large language model. It's not to say that's I can choose any large language model from OpenAI or from cloud and it will just work. It wouldn't. You would have to pair your large language model with the application itself. So yeah, that's so yeah, if you have time, that's so yeah, come visit us at WASM-Edge, and we are really looking for more open source contributors and to adapt it to more devices. And that's it. Thank you.
So the project you just mentioned is open source?
Everything I talk about here is open source.
Okay.
Yeah.
Also, another question. The first demo we gave was for chemistry.
Yeah.
That part of the knowledge base is use RAG or use fine tune?
So we did not fine tune the model, but we did a lot of experimentation to say, can we fine tune the model to make it become a chemistry teacher? And the answer is no. And then that's also some of the things I should have looked up, papers that people publish. That people have repeatedly said the fine tuning give you style, but doesn't give you knowledge. So you can't add new knowledge to the model by fine tuning it, but you can fine tune the styles. For instance, if you wanted to speak like Donald Trump, you can fine tune it. So it's going to use the words that he likes and things like that, but doesn't get more knowledge. So the knowledge is vector database outside.
Vector database. So basically, you use like RAG.
Yes. So, but we do RAG in a more sophisticated way because those models, the key characteristic of those models are they have larger context sets. So you don't have to have those like 100-word snippet, but you can have 4 chapters in it. But in order to put the 4 chapter into the prompt, you have to make the 4 chapters searchable, because the chapter has so much stuff. If I just say what is the melting temperature of mercury, it's going to match to a lot of different places in different chapters, right? Because it's going to be talking about melting temperature about different things in all kinds of places. So what we did is that we used the large language model to generate 100 question and answers from that chapter, serve as a vector index, and then search that index to find the corresponding chapter, and then put that into the knowledge base. So there are lots of small things you can do. That's also to my point. You have to match the model with your infrastructure. Because say a ChatGPT, you may not need that. You may be able to put the whole book in there and just ask any question about the book. Right, because say Gemini, their context list is very long, right? So you may not need that.
But problem is, even though they have pretty big context, but it's too expensive.
Yeah, but that's also why you want to run locally, is that? I mean,
right. That's what I'm looking for. That's why I'm curious.
Yeah.
Thank you.
Yeah, just curious about the Rust knowledge that like some books or texts that they feed it, and how do they package them to share with others?
Yeah, so the knowledge of Rust is so the way we did it is the open source books. So there are a couple books called. There's one Rust by examples. And another one is called the Rust programming language. So those are fairly classic, books that are open source that the Rust Foundation has provided, right? So at one point, the Rust Foundation want to use this, but that's as an education tool, right? So it's we can do a lot more by giving it Rust Q&As because there's a lot of Rust projects that has a lot of issues that you can actually go through those GitHub repository and find out the best practice and things like that. So this is something that we are doing. But our student intern, they have like 3 months. So basically he tried fine tuning and didn't work, and then he he built this knowledge base. So so we are really looking for contributors, to make it better, so that the model can answer Rust question or deep Rust question a lot better.
Yeah, this is interesting because I'm thinking about like an application or like domain expertise, right? Like in the future that people don't share the documentations anymore, share like a knowledge graph.
Oh yeah, exactly. Yeah.
Then yeah, and if it's like compatible based on the WASP match, like I can basically repeat like create myself, right? Like and all my knowledge and I think it's yeah, I think it's just interesting.
Yeah. So yeah, if you're talking about the sharing of the knowledge base, I think, because it's dependent on the embedding model. So it's the embedding model generates, what embedding model does is that it takes a natural language paragraph and turns that into a high dimensional vector. So it's say, we are using the Nomad embedding model. So it's 768 dimensions of, vector space, where it can turn any paragraph into a point in that space, right? So when you search, you do a close neighbor search, and so you ask a question, you search what are the vectors are close by, and you find their corresponding text, right? So you can package the whole vector database, the vector collection, into a zip file and then share with other people. But then the other people would have to have the same model in order to use that file, because they use another model to generate the vectors, then it's going to be mismatched, right? So that's also why I say things are tightly coupled. A lot of the things that we take for granted, that's a loose coupling, probably doesn't work here. So.
Question is how many more minutes we have? 3:20 yet?
Yeah, I think it's the time for the next.
Huh?
Time for the
3:20
next.
yet? Okay, yeah. Yeah, ask some more questions to Michael. Your top popular offline. I think he deserves